All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your questions. And we will try to get to as many as we can near the end of today's webinar. We also have a very, very interactive chat feature, so we hope that you will be chatting up your comments, your questions, etc., to us, and maybe we'll get some incorporated actually into the webinar. And finally, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please, that will be happening at the end of today's webinar, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Expect More from Your AppSec Vendor. Our speakers today are Manish Gupta, who is the CEO of Shift Left, and Randy Gibson, who's the Director of Product Management at Shift Left. Gentlemen, thank you so much for joining me today. Really appreciate it.
Thank you, Charlene.
All right, Randy, I know, yeah, no problem. I know you are going to be kicking off the conversation, so I'm going to put myself on mute and let you get right to it.
Great. As Charlene said, my name is Randy, Director of Product Management. I've been in e-commerce product management for the last 10 years, but I'm new to the security industry. And preparing for this, I asked Manish, our CEO, longtime security expert, a lot of 5 why questions. Manish, you want to introduce yourself?
Yeah, of course, Randy. Hi, everyone. Manish Gupta, founder, CEO of Shift Left, and like Randy said, almost 20 years in cybersecurity. Glad to be joining you on this chat, Randy. Looking forward.
Awesome. So the first one is, why this title? Why expect more from your AppSec vendor?
Yeah. Look, over the last decade, how software is developed has significantly changed. We are all using more and more open source libraries. The emergence of SaaS, software as a service, embracing of the public cloud infrastructure has moved much of our applications from on-prem data centers to the cloud. And in this shared responsibility model, people who are developing software, it becomes their responsibility to protect these applications. Historically, we've done this through sort of network and endpoint security technologies, but when you move these applications into the cloud, they play less important role, and application security becomes more prominent. And hence the title. Given that the times have changed, given the requirements have changed, but application security has become more important, what should we expect from our application security vendors today? I suppose is a relatively interesting topic to discuss.
Manish, let's look at some data here. There's a lot of numbers here around software development, releases, and the speed of how often people release. So why does speed and releasing more frequently matter to the AppSec industry and an AppSec vendor?
Yeah, and some of these numbers, they paint a picture of the speed. The very first bullet kind of talks about the pace with which software is being released, and of course, we as end consumers benefit. I'm a big Netflix fan, and you see sort of new features show up on a daily basis, almost transparently to you. So, of course, speed has significant upside for customers because that allows us to get feature functionality far quicker than we used to get in the waterfall software development model where perhaps we got one software upgrade once in 6 months. But the reason why this creates a significant challenge for application security is, imagine if you developed an application security solution for a waterfall model and you were releasing once in 6 months, and now you're releasing once a week or even faster. Then clearly, if the application security solution that you've chosen is taking hours or days to give you the results, it's rather obvious what's going to happen. Developers will have no choice but to ignore them because they can't be slowed down. Remember, features drive competitive differentiation. They drive revenue. So revenue is the first priority. And in our desire to continue to increase the top line, which of course we should, security is getting left behind.
You said that first statistic when I was doing the research on it. It was funny to see even beyond the internet reaching 50 million users, and then Pokemon Go, but also television and so on and so forth. So I encourage people to look at that. It was interesting seeing the exponential growth of technology and security trying to keep up. All
Indeed,
right, so
exciting times. This is software is driving innovation all around us, and we are benefiting. But also the underside or the soft underbelly of all of this is cybersecurity, and we've seen this happen or show up in the fore in various recent incidents. But we just don't have to look at recent incidents. We know that in cybersecurity there are two key problems. I mean, there are lots of security solutions out there, but there are two key problems in cybersecurity. One is social engineering, spear phishing, and the second is vulnerabilities. And we, for example, spend $30 billion a year on endpoint and network security. We spend barely $2 billion in application security. If we just did slightly better in application security and reduced our vulnerabilities by 10%, it'll go far further, much further than trying to constantly, anticipate and protect the adversary, because that is always a reactive security solution. So fixing vulnerabilities ought to be our number one priority.
all right, I'm going to move forward to the next slide here, and there's a lot going on here, and in the context of legacy code analysis and security analysis, we have this process here, this development workflow. Could you talk about how this impacts the legacy code analysis process?
Yeah, absolutely. So what you see here in front of you is a modern CI/CD, continuous integration, continuous deployment pipeline. Enabled by Git, enabled by various modern CI/CD tools like Jenkins and Circle and Travis. It is these tools that allow our developers to develop much more quickly. And so this notion is that there is a master branch, but then each developer has the ability to take a copy of that code in their private branch, which is kind of what you see here at the bottom, and incrementally develop within their private branch. And at some point when they are partially or fully complete, they'll commit that code. And this allows them to just continue to work. Imagine even in a small team of 100 developers, each developer is doing this in parallel. And when they're done and they're ready to merge this feature that they've just developed into the main branch, that is when they do the pull request, someone reviews this change, and we merge it. And as we talked about earlier, depending upon how fast the organizations are moving, these individual commits within the private branch might be happening multiple times a day. Now, contrast that with application security, which is kind of shown at the very bottom. Typically, application security is run either at the build stage or even today in some organizations at the test stage. And what that does is build or test is happening if there are multiple feature commits happening in a given day. Build or test are happening maybe once a week. And so while there are, in our example of 100 developers, there are multiple feature commits that are happening in one day, we are running application security, or let's say a static analysis scan, once a week. We find a bunch of vulnerabilities. Now, of course, the bunch, as I described them, of the vulnerability we found were because of all the commits. And let's just give it a number. Let's say there were 30 commits. So 30 commits caused a bunch of vulnerabilities. Now, what does the application security team to do? They take this list of vulnerabilities and they go to the development team, because of course, it's the developers who have to fix the code. Application security cannot do that. But now notice some of these simpler things, such as, hey, this vulnerability was caused by which of those 30 changes and which developer made this change. All of these things become very hard to figure out. But somehow, let's say we go beyond that. And then if you were Randy, one of these 100 developers, and you made this feature commit on Monday, and I show up on Friday as the application security person to say, hey, Randy, here is a vulnerability that your change caused. Let's go fix it. Now, imagine what is happening to you as a developer. You made this change Monday. Clearly, between Monday and Friday, you haven't been twiddling your thumbs. You moved on to developing the next feature, or perhaps the next feature after that, because your engineering leadership wants you to work on the next feature. So now, by me asking days later for you to fix a vulnerability impacts your productivity. And I force you to make a decision between continuing to work on the new feature that you're working on, new story that you're working on, or fix a vulnerability. And most organizations, again, driven by revenue, driven by new feature functionality, will almost always choose the former, which is let's go develop the feature, let's ignore this vulnerability. And it is this that continues to cause this technical debt of vulnerabilities to mount. As a result, we see applications getting breached. So that is the problem of using legacy application security solutions that were not designed for modern CI/CD.
That makes total sense. This really resonated with me. I write on the side, and I'll look back at an article I wrote a month ago and think, who wrote this? And I'm assuming developers run into the same issue with their code bases when they're continuously committing and writing code.
Indeed.
So it looks like we have an intersection of many different teams here. We have the developer, dev, and the rest of the dev team, and the application security. Why is this legacy process challenging for those different teams, and are there different needs across those folks?
There are, and I think we can double click on that on the next slide, and this is where we see. First of all, we have to acknowledge that application security is only going to be successful if we allow application security and developers to collaborate. This is one facet of security that security cannot alone fix. And we cannot expect developers alone to get this done because, after all, developers are trained, compensated for writing code, not necessarily for security. And so first, if we establish that there is need for collaboration and the tools that we use should allow this collaboration, after all, that's what gave rise to DevOps. It's the culture of collaboration. So how do we bring that culture of collaboration into application security? First is to acknowledge that. And the second is to understand deeply what each persona here needs. So developers, quick onboarding. Remember, developers are not, for the most part, motivated to do security. And so if we make it super hard for them to onboard a new tool, force them to look at different consoles, we are impacting their productivity, and sooner or later they're going to give up. Consistent workflows, again, it speaks to if I'm using GitHub, GitLab, if I'm using some on-prem SCM tool, the code analysis solution should fit into that workflow. They should be API first. Fast responses. The rule of thumb is that we work with is from the time a developer commits a feature, gets up, to grab a cup of coffee and come back. By the time she comes back, she should have results from application security. Any more than that, and you are causing developers to choose between continuing to work on the next thing or security. Accurate findings, this is of course critical. And of course, false positives will detract the confidence of the developers. No limit on concurrent scans. This is super important also because imagine if you were doing one software development in 6 months, the need for you to scan your software is going to be far lower frequency than if you were doing 30 commits a day. So each of those incremental changes should be analyzed because that is the atomic unit of code that has changed. And very much like the Git process works, we make a change, we commit it. Well, right then and there, we should do code analysis, give immediate feedback to the developer. But in all of this, we should not forget what the application security teams need also, because again, I'll underscore that application security, at least today, we are not at a point as in the industry where developers are motivated or compensated to be responsible for application security. They just aren't. Application security teams need what? They need powerful policy management. They need to be able to tell developers through policies as to what is acceptable and what is not. Because let's understand first, what are application security guys good at? Well, they have a broad view. Developers go a mile deep and an inch wide. Application security goes mile wide and inch deep. They understand the threat landscape because that's what they focus on. So informed by all of this, informed by all of the applications that a company might have, as opposed to a developer who's working on one feature in one application, it is application security that is best suited or in the best position to write policy. Build validation rules, kind of same thing, something similar. Automated scanning. There are customers, prospects we talk to where they're having to have one person on staff 100% of the time just to manage the upkeep of the code analysis solution that they're using. Kick off the scan, and then if it doesn't work, well, figure out what happened, maybe download the latest software upgrade, latest policies, rules. All of these things take a lot of time. In the modern world of SaaS, to continue to use an on-prem SaaS solution boggles my mind. Unlimited API access. Again, CICD, continuous integration, continuous deployment, is API centric. It is built to incorporate multiple tools. And if static analysis shows up to this party without being API centric, we're going to force developers to change their workflows. And all of this is what also causes animosity between developers and application security. So as you can see, developers need a set of things, application security needs a set of things, and we'll be successful with this only if we step back, take a look at these needs, and come up with a solution that caters to both of these personas and all their needs.
That makes a lot of sense, Manish. One of the things I was thinking about is looking over here at the left of concurrent scans, and then over at the right here with AppSec automated scanning. And I was just wondering, we looked at legacy code analysis. How does modern code analysis kind of meet these differing needs?
Yes, let's double click on that, right? Let's take a look at that CI/CD pipeline that we reviewed in the context of a legacy code analysis solution and see how do we deliver on all of these requirements through a modern static analysis solution. And so notice this is the same CI/CD pipeline. What has changed? Well, in the private branch of a developer, after the commit and the pull request, notice we are now able to insert SAST. So first key observation, SAST, static analysis, which was either being done at the build or the test stage, has moved left, far left into the CI pipeline. Now, one could argue, one could question, well, why don't we do this SAST instead of here? Why don't we do it in the developer's IDE? Well, isn't that the place where they're writing code? And before they even commit, could we not come up with a code analysis solution that as developers are writing is telling them what not to do? Well, few things for why that is a suboptimal solution. Number one, we asked, and this is a survey that is available on our website, we asked, and this is an ongoing survey, so I forget what is the number of software developers who have responded to it, but we asked them, where in the CI/CD pipeline does your productivity get impacted the most negatively when code analysis scan is done? And the answer overwhelmingly was in my IDE. So now let's understand why that is the case. We know code analysis is a very compute and memory intensive application. After all, it is a piece of software which is trying to automatically understand another piece of software. Super hard problem. Now, when we understand that a code analysis scan, which is memory and compute intensive, standalone on a massive server, still takes seconds to minutes. Now we expect that same code analysis solution to be integrated into a developer's IDE on his or her workstation and be able to deliver results in real time. Well, that's just mismatched expectations. And so what typically happens, therefore, is what vendors land up providing in the IDE are superficial things. Like, oh yeah, I see you have these curly brackets here open, but you haven't closed them. Okay, well, great. Or because they don't have the entire context of the application, they only are looking at a few lines of code, they land up providing developers with a lot of false positives. And the best parallel that I'll give you is in Microsoft Word, there was an annoying Clippy that showed up almost a decade ago. I'd ask how many of you in the audience actually use that on a regular basis. I know very few people. Why? Because it's just constantly is annoying. And key is that it hinders the very creativity of either writing a document or writing code. Last shortcoming of this approach is application security, and the company as a whole is responsible for making sure that the risk of this application when deployed in production has gone down. Now imagine that we've taken this application security and we've distributed across IDEs in developer environments. Awesome, great. How do we know that developers are adhering to those recommendations that are actually fixing vulnerabilities? We don't. So the alternative of doing a scan in the pipeline, we cannot do away with, because that is the only way we can find out what vulnerabilities haven't been fixed. And so we arrive at, now that all this is not to say that we should not be doing anything in the IDE. Of course, IDE is the place where a developer lives. And so that is the, IDE is a place where we should be providing feedback once a code analysis is done. So that is sort of double click on what should be done in the IDE and what shouldn't be done in the IDE. But so we come back to this. SAST notice, as we were talking about, is being done within the private branch. And all of the problems that we talked about in the previous slide, such as while developers are doing 30 commits and we're doing one code analysis, go away. 30 commits means 30 scans. We no longer need to worry about which developer made this change. After all, this is the private branch of the developer. We no longer need to worry about forcing the developer to choose between fixing a vulnerability or adding a feature, because the developer just added this feature. And she gets instantaneous feedback within a matter of seconds to minutes, depending upon the size of the code. Hey, what you wrote caused this vulnerability. And what's more, based on the policy of the application security team, this is a SQL injection in an application that is customer facing and handles sensitive data. Absolutely, this pull request is denied. Now we are starting to see the advantage of automation.
Awesome. Yeah, everyone remembers Clippy, Manish, but nobody remembers using it.
That's right.
All right, so concepts are great. Let's jump in and take a look and see how this looks in real life. I'm going to open up GitHub here. Are you able to see my screen clearly, Manish?
I can.
Perfect. So what we have here is a pull request in my GitHub account. And what happened is we have a static analysis tool, shift left static analysis tool, that ran and then failed at within the build rules. And if we click in here on the details of the static analysis, you'll see what happened here is this static analysis where Manish was discussing in the CI pipeline ran in 2 minutes. So they had plenty of time to go get that coffee. But also the build rules failed, and that gets in detail here. But the immediate feedback here in that modern code analysis is right up here. So it failed. Now why? So we have build rules in here, or those AppSec policies that he mentioned. And we have some vulnerabilities, 54 critical, 84 moderate, and 44 are just information related. And the threshold is 0, as you can see here. Now, what we've done, a shift left within our SaaS tool, is developed a UI for this GitHub static analysis process. So I'm going to go ahead and click into this and jump into the UI. So this is just getting more information about this scan. Let me zoom in a little bit. So here we have a dashboard and of this demo application, this Java demo application, 186 vulnerabilities, and they're prioritized here by the severity. And what you can see over here is as you fix each vulnerability, so I did a scan earlier this week when Manish and I were preparing, and then you can see that they start to drop off a little bit because I started making updates and fixing some of these vulnerabilities. And you can see here in this scan on 4/15 yesterday when I ran this, there's 6 vulnerabilities that were fixed. And you have a list here. But just to go and show you back on the GitHub section, what I'm looking at another pull request here. And all I did was just comment out this vulnerability and merge that pull request back. And that's the update you're seeing here where it dropped 5%. Manish, you want to add anything as far as these vulnerabilities related to what you were mentioning?
Yeah, 2 things I would add. One, to the audience, they might be wondering, well, looking at 104 findings, really, Manish, you expect me after a feature commit to fix 104? So yeah, look, this is a representation of real life. When you will be adding your feature commit, your addition, unfortunately, that code is not going to be pristine. It is going to have pre-existing vulnerabilities. Now, clearly, you are not responsible for fixing all of the pre-existing vulnerabilities. So we won't do this in the interest of time, but just notice that right under finding trends, you have a version compared to version. And this is a quick way to see for you to say, maybe perhaps you were the person who did this feature committed on 4/15 at the very right. Well, you can quickly compare it to the one previous to that and that'll immediately tell you, hey, how many are the vulnerabilities that are new that you have introduced because of this feature commit? So that's one thing that I'll say. And the other thing that I'll say is, in the previous screen that Randy was showing, it was 2 minutes and 15 seconds. And there are clearly solutions out there who say that they can do this in seconds. So look, I think I wish that speed was the only important metric. We could, of course, run this code analysis extremely quickly, like in a second, but not find anything, right? And my point being that there are 2 things that are important, not one: speed and accuracy. Speed is easy for you to determine. You take your application, scan it across 2 or 3 different solutions, and it'll tell you, this is how long it took. The other is accuracy. And maybe you want to do this with your application, maybe you don't, in which case, if you don't, OWASP benchmark has been around for a while. And unfortunately, majority of the vendors still have not tested OWASP benchmark. And if they have tested, they're not public or very forthcoming about what is their score on the benchmark. And that should start to make you question, why is that the case? So key takeaway, accuracy and speed, not one.
Thanks, Manish. And right now we're talking about source code, right? We're not talking about any libraries or open source.
Correct.
Okay. So I've heard and have seen around like 80 to 90% of code bases or just libraries sometimes, especially some of these e-commerce companies. So how does an AppSec vendor adapt to these facts? And I'm going to bring back the slide here for you.
Yeah, no, thank you. So you're right. to date, code analysis has consisted of sort of two segments. One, static analysis, which looks at the application to find vulnerabilities, unknown vulnerabilities. And for whatever reason, there has been another category called SCA, software composition analysis, which focuses on telling you what vulnerabilities exist in the libraries that your application is using. And these two solutions to date have remained separate. What has happened is several companies, either code static analysis companies, have acquired software composition analysis tools, or software composition analysis companies have acquired code analysis tools. But nonetheless, what the important point to take away is these two approaches continue to, even though they might be on the same product, same platform, continue to look at this two different ways. And that has always baffled us. And the reason is because imagine you're a developer, you've just developed an application and it has 100 dependencies. Well, when you deploy this application, are you deploying a bag of dependencies which consist of 100 dependencies? Of course, the answer is no. Are you just deploying the application separate from the dependencies? Of course, the answer is no. You are deploying the application with some of these dependencies. And that is what the attacker gets up and looks at and says, yeah, all right, I see some custom code, I see some dependencies. His goal is to exploit the application. He doesn't say on Monday, I'm going to focus on custom code, and on Tuesday, I'm going to focus on dependencies. So it is high time we sort of brought these two approaches together. And that clearly shows, as we will talk about in the next couple of slides, the power of analyzing the application comprehensively.
So we're seeing here the 2,700 tickets. Perfect. Can you talk about that a little bit, Manish?
Yeah, so this is, so we wanted to show to the audience that as we have come out with our intelligent software composition analysis, why is it intelligent? How is it different? Well, so we did this experiment across about a dozen of beta customers where we took 49 of their apps that they submitted to us. Across these 49 apps, we found 2,761 open source vulnerabilities across 718 packages. What this translates to is for the development team across these dozen customers, there were 2,761 tickets that they needed to take care of. I'm sure in the audience you're familiar with this problem where you're just constantly given a long list of dependencies to upgrade because they happen to be vulnerable. So that is what this slide is saying. And the upshot, of course, is upgrading dependencies is non-trivial. Yes, if you are a fairly new organization and you have almost negligible tech debt, then yes, it is easy for you to keep up with the latest version of the dependencies. And to the extent that the APIs haven't changed, you can easily upgrade from the latest version to the one that just came out, where perhaps a vulnerability got fixed. And if that is the case, well, you don't need what we talk about here. But if you are a company which has any amount of tech debt and you find that upgrading dependencies takes time, any more than like 5 minutes, then keep listening.
So how can we make these findings much better? This 2,700, what can we do about that?
Yeah, so I think the question that we should be asking is, okay, so I'm using these 718 packages. I get that. But just to use Java as an example, these 718 packages might be in my pom.xml file. But some of these packages have existed for like 3 years when whichever developer who was writing this application 3 years ago added this library, but since then we've stopped using it. But it just happens to be in that pom.xml. Okay, so that's the first level of prioritization we can come up with. Is the dependency actually used in the application? Furthermore, if the dependency is used in the application, are we using the vulnerable function within that dependency? Because not the entire dependency is vulnerable, just a particular function is vulnerable. And then the last and the most important is, well, is this dependency in the attacker controlled path? And so, as you can see here, that's kind of what we talk about, is how can SCA be more accurate? And this is achieved because we are doing both static scan as well as software composition analysis together. We are converting the application, which contains all of these dependencies, into one, what we call code property graph. And it is that code property graph that we analyze for dependencies. We analyze for software composition analysis, that we analyze for vulnerabilities as well as dependencies. But because of the attacker reachable capability, it allows us to significantly reduce the dependencies that actually need to be upgraded. In the beta customers, we were able to reduce it by about 92%.
Wow. And this reachability concept, can you speak to that a little bit more, the attacker reachability? Like, how's it different than what people are doing?
Yeah. The SCA solutions largely focus on, hey, you're using this dependency, and is this version vulnerable or not? And if it is, the only choice you get is to go fix that, upgrade that dependency. Yes, there are some solutions that have now started to add like AST, syntax tree based analysis, where they are slightly better. But at the end of the day, what really matters is not just syntax tree. You have to look at the entire analysis, which is syntax tree, control flow, data flow, configuration data, all of that analysis put together, which is precisely what we do for static analysis. Once you do that, that is for the dependencies in question, because imagine you're looking at a graph, and in that graph, somewhere in that graph is a dependency. Somewhere in that dependency is the vulnerable function. We can identify that, and then we can look at whether the attacker can reach that vulnerable component. If they can, well, you should be upgrading it. If they cannot, maybe you can buy yourself some time. That is the key. Now, the best way to be able to tell the difference between what I'm talking about, which might seem marketing speak, versus what you might be hearing from some of the other vendors, is the following. If ever a vendor is able to give you an alternative to upgrading the dependency, then you know that they are actually doing the analysis with the dependency in question. Let me clarify. If you remember when Randy was showing you the interface of the static analysis solution, we were able to see the data flow. And if in that data flow we can now stitch the dependency, and if it is attacker reachable, well, then is it not possible to mitigate this vulnerability by doing something in our custom code as opposed to only having to upgrade the dependency? And that is what we provide you for every vulnerable dependency that we've highlighted is attacker reachable. And maybe you can show this in the interface, Randy.
Let's do it. Let's jump back in. We're now back here at the SaaS tool, and we have this dashboard here that we were discussing earlier when we did our static analysis. But over here, you can see that there were some open source vulnerabilities, 76. And down here, you have different OSS vulnerability packages. And when you dig it deeper in there into the open source vulnerabilities, we can then get to, okay, we have 76, but how much are reachable? How much are actually need to be fixed and prioritized? So what we've done here is analyze how much of these are actually reachable, and it looks like 55 are actually unreachable and 21 are reachable. So I'm gonna go ahead and filter those open source vulnerabilities. Now we have here, you can click into this. Let's just check out the first one. And we have a description here. This is a Apache async request, it looks like. And there's suggested mitigations to solve this. But also we have here some of our source code that's reachable in 14 of the findings as well. And you can see that if we clicked onto this, we could even dig further into our source code to find out, okay, there's a sensitive data leak. Now you can see within this open source vulnerability, we have 14 reachable findings, which what we're seeing here. But I think going back to what Manish was saying, the key point here is we had 76, but really only 21 are reachable when we do the analysis with our code property graph. Manish, you want to add anything that I missed potentially? That now that you have the interface in front of you.
The only thing I would add is for it to really hit home amongst the audience is in this one application, we were able to get this down from 76 to 21. That is a savings of about 55 dependencies that you don't have to upgrade. Ask yourself the question, on average, how long does it take for you to upgrade a dependency? If it is half an hour, that's 25 hours saved. If it is 15 minutes on average, even then, this is a savings of about 12, 13 hours just for this application. That is the power of intelligent SCA.
Awesome. And I'm being a time cop here. I see we have about 19 minutes. So I'm gonna keep moving and bring back the slides here. If you don't have anything else, Manish.
Yep.
Alrighty. So this is a lot. We have new SaaS over legacy SaaS, and we have new SCA over legacy SCA. How easy is it for dev and AppSec teams to start solving these problems today, right away? Like, what are some of the challenges?
Yeah, I think when we have asked developers the question, hey, we are telling you about these vulnerabilities, why aren't you fixing them? Apart from the productivity and apart from getting this capability integrated into the workflow, apart from accuracy, the other questions that often get raised are, well, number one, Manish, what is SQL injection? I'm a developer. Yeah, I've gone through, the education that a developer goes through, but not necessarily cybersecurity. So you're telling me I have a SQL injection vulnerability. What is it? What does it do? Like, what is the downside if I don't fix it? And if I do fix it, how do I fix it? So all of these questions come up, and this is where we just have to help developers get educated in security while they're doing their job.
Makes sense, and 60% of vulnerabilities not being fixed. Seems crazy.
Indeed.
So can't they just Google a quick solution? And why are they leaving 60% of these undone? Not a developer, remember, but it seems like it could be just a quick Google to do find out a solution.
Yeah, well, let's try it. Let me be the developer for a change. I'm going to be a horrible developer, but let me be. So let's say what is XSS? So I go and Google, and as you can see, we've cut and pasted this from a browser, but 5 million results show up. Okay, and so what is a developer going to do when he sees 5 million results? Of course, he's going to click the first to the second. I look this using ES API to fix XSS in your Java code, Computer Weekly. I mean, all the right words there. Okay, let me click it. It's not very old. It's 2012. All right, so I click it and I get to this OWASP.org page. But most, perhaps 90% or more of the ES API, blah blah blah. Essentially, the recommendation is not to fix it in this manner that this using ES API is recommending it. Right? Now, of course, this is all with the assumption that I'm a motivated developer, that I have a ton of time, and that I am taking the time to go and take all of these steps to be able to fix it right. What is more often than not that's going to happen? Number one, I did the first search. Oh boy, too many results, 5 million. All right, tell you what, I'm just going to come back to this later. Or two, oh, using ES API, perfect. That sounds good enough. All right, let's do it. And what happens? Application still can be breached.
Manish, this seems out of an AppSec vendor's control. How could they solve this problem?
Yeah, no, absolutely. And let's talk about that in the sense that what is the alternative? What are some ways that we can fix this problem? Well, one is we can now ask all our developers to go on month-long training courses to get better at cybersecurity. Yeah, perhaps we should. Not going to happen. Remember all the features and all the competitors that we got to compete with. And after all, developers are meant to write code. They're not motivated, neither compensated to do security. So not many of them are going to really want, even though they want to do the right thing, they don't have the luxury of taking the training. But as we are seeing in this conversation, it is developers that have to do this because application security can be fixing it. So essentially, I believe the compromise that we come to is somehow we have to provide just-in-time training to developers. And so let's talk about how we do that. Right. So we come back to the same CICD pipeline. By now, you've been used to this particular slide. Someone commits vulnerable code, run the scan, and we tell you the vulnerability. But now, what if? Let's make the example specific. Let's say it's SQL injection vulnerability in Java. Yeah, and so I don't want you to go and Google. I can't expect you to go take a training course, which is a month long, because it's not going to necessarily just tell you about fixing SQL injection in Java. It's going to start with, yeah, this is cybersecurity, this is a vulnerability. And yeah, let's use Python example, because of course, Python is a very often used language more in today's world. It doesn't help you. And also asks you to go out of context of what you were working on. So what if I told you everything about SQL injection, how to fix it, what happens if you don't fix it in a 2 to 3 minute video? That, we believe, is a good solution to this problem that we're talking about, Randy.
So let's take a look and go back into the same application that we analyzed and see how this looks. I'm gonna go back to our dashboard. So over here we have our Java demo. I'm just gonna scroll down and go to a vulnerability type, let's say cross-site scripting. And here we have 17 vulnerabilities. So I'm just going to click on this first one. And now you see we have our data flow that you mentioned before, identifying where this vulnerability lies in the code base. But over here, we also have the security training that you were mentioning. So in context, we go ahead and click this. Shift left provides contextual developer training here on 22, depending on the vulnerability type. This one has 22 steps, but it walks the developer through a penetration test, has them walk through a username, password, and walks through and has them solve this particular problem, fix this vulnerability in the context of XSS, so they don't have to go around and Google and find the 5 million search results that Manish was showing before. And this goes beyond XSS, of course. We also have sensitive data leaks. So just clicking on the first one, we have 70 vulnerabilities here, and you can click on the security training as well. And now we again have contextual developer training, only 10 steps here, but you can see it sets up the application, talks about the attacker, password, and then the mitigation at the end. So now the developer has training in the context of this particular vulnerability type. Manish, you want to add anything in regards to some training now that you're looking at the user interface?
Yeah, two things I would add, Randy, that we haven't covered is one is the other benefit of this approach, apart from helping developers fix this vulnerability, is because everyone in this organization that is using this tool is watching this video to fix this vulnerability. Now we are going to see, a semblance of similarity across how this vulnerability is fixed across developers. That is what we want as an organization, isn't it? We don't want developer one to pick the second result of the Google search. Developer two, instead of typing what is XSS, maybe he types cross-site scripting and lands up getting a different set of 5 million results and lands up picking a different way of solving this problem. So that is one, which is, of course, we want all developers in a company to be following best practices. Second, this approach allows a company to, what you haven't shown in the demo, but that's fine. In the interest of time, we likely won't be able to get there. But the security team or the engineering team can recommend a particular approach right here in the console to say, hey, look, instead of using this API, we want this particular API to be used across this application for sanitizing these kinds of inputs. So again, and we could get even further with this to finally now say, well, now that we made this recommendation 9 months ago, and now everyone should be adhering it, I'll tell you what, we will fail the build, we will fail any pull request that is not using this particular API to sanitize inputs. So now notice that we've gone from almost like vulnerability identification to vulnerability fixing to almost like firewall rules in terms of implementing best practices. Again, automation. That is the only way we are going to be able to get better because the pace with which we write software is constantly increasing.
Great, Manish. And I know I want to leave some time for Q&A, but in the interest of time, feel free to go to shiftleft.io, sign up and test this out yourself. We have free accounts available, premium trial, 15 days, so you can see all of these features in action. I'm going to come back here. And I just want to give you to give a quick summary, Manish, just so we don't forget some of these key points, and then we could open up to Q&A.
Of course, Randy. Yeah, I think the way I would summarize it is, look, number one, if application security is not currently a high priority, I encourage you to make it a high priority in your company. Number two, if you are using modern software development methodologies like CICD, or you plan to sometime in the near future, consider solutions that are purpose-built for the agility that you desire your organization to achieve. Try not to think about the silos that have existed in the past. A SAST and an SCA, they have to be different solutions. They have to work differently, even though they might be on the same user interface because the companies have come together. That won't allow you the level of prioritization, informed prioritization that we talked about. And finally, let's not just stop there. Let's understand and appreciate that developers have a challenging job. We are asking them increasingly to do more and more and more. And how can we help developers as opposed to just blame them that they're not fixing vulnerabilities?
Great. Let's jump into some questions from the audience. We have 7 minutes left.
Yeah, we've got a couple questions that have come in, and I think we can get to 3 or 4 of them here. Let's see. First question is from Cedric, who asks, would unlimited API access also entail repo access?
Would unlimited API access also mean unlimited repo access? And the answer is no. I'm assuming what you mean is if you bought shift left license that you can scan any number of repos. And the answer is no. Our licensing model is based on number of developers, and we give a fairly large multiple between the number of applications that can be scanned per developer. And so that is how we come up with the number, sort of the upper limit on what you can scan.
All right, great. He has a follow-up question. How is reachable and unreachable defined again?
Yeah, sure. So the way the reachable and unreachable defined is, imagine you're using a dependency in your application. As we discussed, the question really is not whether the dependency is vulnerable. Yes, that's important, but whether that vulnerability is reachable by an attacker. Because if the attacker cannot reach that vulnerability, then the likelihood of him being able to exploit that application because of that vulnerability in the dependency is negligible. Now, that is perhaps, this is not to argue that you should not upgrade dependencies. There are other reasons. There is always best practice to continue to reduce technical debt because you want to be embracing the latest version of the dependencies. But armed with this information, that this particular vulnerability in this dependency is not reachable, you can buy yourself time. You don't have to fix it right away. You can go upgrade dependencies that are reachable. You can go rather fix vulnerabilities in your source code that do make your application vulnerable. So it's about taking a risk-informed decision on what you need to be doing right away versus something that can wait.
All right, great. So we have about 5 minutes to the top of the hour. I think we can get to one or two more questions here. Bob asks, does shift left complement the layers of security provided by cloud WAFs in place, or is there some overlap? Do they work together well for a separation of coverage?
Oh, that's a great question. Yeah, what we do, which is code analysis and cloud web application firewalls, are very complementary. In fact, if you take the information coming out of these two solutions and you marry them, that is when magic happens. Let me tell you why. Imagine you've deployed an application in AWS, you're using Cloud WAF, and Cloud WAF, you get an alert, attack, seen. What are you supposed to do? Well, attack is seen, but you want to know whether this attack was targeting a vulnerability and if that vulnerability exists in your application. So just partially, the WAF telling you that it saw an attack is not very helpful to you. But coupled with this knowledge that I saw a SQL injection pattern come in, and I see your application is a SQL injection vulnerability, now suddenly adding those two pieces of information, this is something that you need to worry right about now.
All right. All right. Well, we are about 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for the question and answer period. I do want to thank everybody who did submit questions. And if we didn't get to your question, I apologize. But please know that the folks at Shift Left are getting a copy of all of the questions that came in. And I am sure they'll be more than happy to follow up with you offline and get your question answered. Another quick reminder to the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website. So you can always go look for it there. Just go to securityboulevard.com/webinars and look in the on demand section, and it should be right there waiting for you. All right, real quick, before we close things out, let's do the drawing for the $425 Amazon gift cards. Our first winner today is Justin M. Congratulations, Justin. Our second winner is Steve W. Congratulations, Steve. Our third winner today is Carlos M. Congratulations, Carlos. And our final winner today is Brian M. Congratulations to Brian. Congratulations to all four of you. We will be getting in touch with you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. Manish and Randy, thank you both for such a great presentation today. Lots and lots of great information for organizations that are well on their way to the application security journey. So thank you again. Really do appreciate your time and your expertise.
Thanks, Charlene.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.